So you've heard about the rich agency-wide experience we've had in this program, and that allowed us to develop some insights on systems engineering across the agency that we'd like to share with you today. We've categorized these in 3 areas: world-class capabilities, knowledge empowerment, and strengthening systems engineering culture. So some of the amazing facilities we saw on our different modules and details. Just to name a couple, the Plumbrook facility at Glenn Research Center, an enormous lead-lined chamber originally made for testing nuclear propulsion that's now repurposed to space environmental test, or extensive additive manufacturing capabilities at Marshall Space Flight Center. But as we went to these different benchmarks, invariably one of us or more of us in the class were surprised at what we were seeing. We were not aware these capabilities existed. And it occurred to us that there's a lot of potential for collaboration if we can have better awareness and reduce the barriers to cross-agency use. Also, a lot of these facilities are being repurposed, and this is overall a good thing, but we think that this approach by itself could put these facilities at risk. In just about every case when we talked to people at a facility, they were expressing that they were struggling for their existence. So we had the privilege of going to the Cleveland Clinic, and we saw this amazing facility in the picture behind me called their model room. And they've dedicated a room to having these huge scale models of their facility so they can see how their different facilities integrate, where they are, how they work together. It's clear that they devoted a considerable amount of resources to this to make this non-trivial scale model and devote the space for this purpose. So what if we had something like this at NASA? If we had a model of NASA, just a concept here is a 10-sided polygon, 1 side for each center. And with this should not just be a picture, but this is a view into a live database where it's a live model. You can categorize the different capabilities by color, for instance, space environmental test, prototype manufacturing, analogs, and you could select a category, and that would cause the model to show you capabilities within that category. When you select a face, you can see what capabilities are at the particular center in that category. For instance, space environmental test, we see the microgravity drop chamber at Glenn Research Center and Plumbrook. We could select Johnson, for instance, and see an environmental test chamber or the neutral buoyancy lab. So this could be a website that anyone at NASA could access, or it could also be a virtual reality tour of NASA, much like we got an actual tour of NASA in this program. So next, for knowledge empowerment. Again, SELDP deepened our appreciation for the amazing legacy that is our agency. We know we have extraordinary accomplishments, but to meet our future challenges, we must be empowered by what we know and be able to access that information in a dynamic and agile way. Some of the observations we had on knowledge were in these categories. In retention, at JPL, we heard stories of how information from past programs, when it transitioned from a paper filing system to an electronic filing system, that some of that data could have been lost. And many who knew how to access the data prior to the transition did not have as easy a path or knowledge on how to get to that data now. Also, it's clear that when programs end, often there's not adequate resources allocated to do a clean closeout of that program and archive the critical information. And it's just too quick of a move to the new program after that. We'll also do a better job of capturing what we built, but not why we built it the way we did, which is really the critical piece of knowledge. Also, accessibility and availability. Configuration management issues at Kennedy Space Center. They're repurposing all of their massive ground infrastructure for new programs. And we heard about how drawings are on vellum or microfiche, if they even exist or can be found. And when we archive information, it needs to be done so in a way that we know we can use it and we can get to it. We heard at Langley that the knowledge for building one of the big fan wind tunnel blades is lost, and the tooling is lost to do that. So that's a single point failure of a capability in this agency. So we need to allocate the resources to have the long-term retention and access. The final aspect of knowledge is culture. Culture is about people, it's from the heart, it's about passing it on. So this is mentoring, this is Graybeard Consulting. The NASA Knowledge Map and NESC Knowledge Academy are good examples of success stories that are in work on these fronts. It's also how the organization uses its knowledge, so sort of the use case for the knowledge, if you will. Heritage reuse is a good example that we do. Also, lessons learned are very popular. JPL has a good example of how they relate their lessons learned to standards development. On our Johnson module, we got to see many things. Among them was the International Space Station control room, as you see here. And as you look at this, NASA is no stranger to management of knowledge. There's a whole diverse set of information here in this control room that operationally we do a really good job of managing in a very dynamic and agile way. So imagine if we could manage the 50 plus years of knowledge within our agency in a similarly dynamic and agile way. For example, systems engineers, chief engineers may have a knowledge dashboard that allows you to, for instance, some years down the road, see how the Atlas V was certified for human spaceflight in the Commercial Crew Program. Strengthening SC culture. Again, we know that NASA is world-class in systems engineering. General Electric is modeling their systems engineering processes after NASA, as we saw at our benchmark of GE Oil and Gas. We saw great examples of model-based systems engineering employed in major programs at JPL, for like Europa Clipper and Mars 2020. Despite us being world-class in systems engineering, we believe that there are still cultural barriers to systems engineering. It's often imposed from the top down or seen as a tax. It's seen as being document-centric and not information-centric, as it really should be. It's brought into projects later in the life cycle when opportunities for its use are missed. And the science of systems engineering, the artifacts that it produces are often stressed a lot more than the art of systems engineering. And it's the art that saves lives and makes missions successful. So our charge for the future, for the challenges that we have before us, are to ask ourselves, how can we do this better? So some ideas, let's go back one, please. Some ideas that we have for doing systems engineering better. More consistent training and development of system engineers across the agency. Many centers have great programs for system engineering development. This program is a great agency-level opportunity example of development, but we still see inconsistencies at the level that different centers offer in this realm. Many people grow up in disciplines many years before getting integration roles, and this is a natural progression of one's career, but we should not overlook the early exposure to integration, to systems thinking, and not miss those opportunities early in folks' careers, so we should design ways to have that exposure. Definitions. JPL calls their systems and engineers and chief engineers something different than Goddard calls them, which is something different than JSC calls them. Realizing that systems engineering can and should vary by mission, by center in its implementation, still we need consistent definitions across the agency so we can communicate. And again, the art is more important than the artifacts. We saw at Langley in our last module that there was a great example of practicing the art of systems engineering in a rapid development lab. And we know other centers have the rapid development labs as well. We need to use those more. So 50 years ago, roughly, the first man walked on the moon. And of course, this was a daunting challenge and an extraordinary accomplishment. We see the challenge today as what's on our plate as future leaders of this agency and the current leaders sitting in this room is extending our presence beyond the Earth. And to do that, we must look at everything we do and everything that makes us great and make it better. So we've had the privilege of a uniquely valuable experience in this program, but we're only 7 people. We think for real change, we need to see 100 people going through this program every year. Many people are leaving this agency, as Lisa talked about. We need to transform the culture now. The future holds a tougher challenge, and we need to do the systems engineering job right so that we can do the work we need to ensure our future. And I would just like to offer that we have a handout of the content of this presentation in the back on the table over there if anyone would like one afterwards. Thank you very much.